we'll start this discussion with just writing down the rules here. When we want to solve equations with square roots, there's three things that we want to do. First of all, we're going to use the golden rule, which is whatever you do to one side of the equation, you have to do to the other. But this time, instead of using the golden rule to get the variable by itself, we're going to use the golden rule to get the square root by itself. So the goal here in this first step is not to get the variable by itself, but it's to get the square root by itself. And we did that in the opener. Atlas did it in his opener where he added 2 to both sides, or added 3 to both sides to get the square root of d by itself. So the first thing you're going to do is get the square root by itself. Once you've done that, then you're going to square both sides of the equation. Anybody want to guess why we would square both sides of the equation?
Because the square root.
What about the square root? What do the square and the square root have to do with each other?
They both equal some kind of number.
What do the square and the square root have to do with each other? Good answer. So the square and the square root are inverses of each other. So we're going to square both sides of the equation so that we can get rid of the square root. Because the square and the square root cancel each other out. Go ahead and write that down. That's an important thing to know. You got to know why we're doing this stuff, otherwise it's not going to make sense to you when you're doing it. Okay, so we're going to, once we get the square root by itself, we square both sides, and that's going to get rid of the square root. Now, after this step, we're going to have an equation without a square root in it. So we know how to solve those equations, right? At that point, we're just going to solve as we normally would. We would use inverse operations. If we have a variable divided by something, then we would multiply. If we have a variable plus something, then we would subtract. We would solve as usual here. Now, nothing's different in these equations about circling the variable, drawing the line of equality, and all that stuff. There is one thing that's a little bit different that we're going to do. We're going to circle the variable, but we're also going to identify the square root because in the first step here, we want to get the square root by itself. All right, so let's go ahead and do an example together. In this first example, the square root of c plus 2 is equal to 5. We want to figure out what c is. So write the equation down. Knowing what we know about solving equations, it would be tempting to say, well, we need to subtract 2 from both sides. The problem is that plus 2 right now is inside the square root. And we can't subtract 2 when the plus 2 is inside the square root. So the first thing we have to do is get rid of the square root. Now, if you look up at your notes, the first step says, use the golden rule to get the square root by itself. Well, do we have to do that step here? Let's look at what we've got. First of all, I'm going to circle the variable just like we always do. We'll draw the line just like we always do. But I also want to identify the square root. So I'm going to identify the square root by putting a box around it. There's the square root. I want to get that square root by itself. Well, that seems kind of silly in this problem because the square root's already by itself.
The square root already by.
Yeah, good, Claire. The square root's already by itself. There's nothing else over there. Okay, so the first step's done. So what's the second step?
Square both sides.
Square both sides to get rid of the square root, right? So let's do that. Let's square both sides. I'm going to square this side here, and I'm going to square this side here. So we're using the exponent of 2 here to get rid of the square root. What happens on the left side when we square it? What happens to that square root? What's that? It goes away. The square and the square root cancel each other out. You guys remember this from when we were simplifying square roots? We were doing problems like the square root of 25, and then we rewrote it as the square root of 5 squared, and then we said the square and the square root cancel each other out and the 5's left. It's the same thing here. we're showing that the square and the square root are inverses of each other. When the square root and the square cancel out, what's left? C plus 2. And then on the right side, we have 5 squared. What is 5 squared? And we're done, right? No more square root, we're finished. No.
Don't look at me like
Gotta do what?
like
Yeah. Here's where we solve as usual, right? We want to get the c by itself still. So how do I get that c by itself? Subtract 2. So subtract 2 on both sides. The 2's cancel each other out. So what's left on the left side? On the left side? I think you guys have trouble with left and right, don't you? And on the right side? Claire's the third person to do it today, so I'm not just making fun of her. I'm making fun of 3 people. Lucas did it, and somebody else did it. What's 25 minus 2? Guys, what's 25 minus 2? Let's stay focused. Does that make sense? Let's do another example. So this is a very similar example.
Can we try it first?
Uh-huh. Go ahead and give this one a try on your own. See if you can do it the same way as we did the last one. I'll start it. Circle the variable, draw the line. Who wants to tell me what to do next? Claire?
Do it just like you did the last one.
Okay.
Like box the whole thing.
Okay, and like I said, you don't have to put this box here.
I just
That-
asked you that.
Sorry. That's up to you. That box is kind of like the circle for the variable, except we want something different for the square root. Remember, the first step is to get the square root by itself. Now, just like the first problem, the square root is already by itself, so we don't have to do that first step. The second step is what?
-2 on both sides.
Okay, good. So we want to square both sides. So we're going to square that. That's going to cancel out the square root. And we're going to square this to keep it balanced, to follow the golden rule.
Okay, and put
What-
a line.
Okay, so I'm going to draw this line here so that it goes through the square root and through the square.
My line be touching my ego.
If just don't think that it canceled out the e. Okay, the only 2 things that are canceling here that are going away are the square root and the square. So when those go away, Claire, what's left on the left side?
E plus 14.
Okay, and on the right side we have 2 squared, which is the same thing as 2 times 2, which is 4. Okay, good.
And then minus 14 on both sides. And then cancel E.
Okay, so the plus 14 and the minus 14 cancel, and we get e, you said? And on the right side?
-10.
-10, good. So one's positive, one's negative, which means we subtract, right? And 14 minus 4 is 10, but the bigger number, the 14, is negative, so we get a -10. Does that make sense? You guys feel okay about that one?
Yeah.
Okay.
Can we do this right here? Learn nothing else.
Now, let's do this one together. Go ahead and write it down, but we'll do it together. You can start by putting a circle around your variable and drawing the line through the equal sign. It is really important here that when you write your equation down, you don't write it like this.
Right.
Hold on. I'm going to show you. What's wrong with this compared to this? The -3 is what? Yeah. So in the problem, the -3 here is outside of the square root. The way I wrote it down, it's inside of the square root, and they mean completely different things. You would get different answers if you wrote it down one way and not the other. So be sure that your square root does not cover the 3, and it looks like that. So it's over the +1, but not over the -3. Circle your variable. Draw your line. Extra credit? For what? Now, the other thing I'm going to do here to get started is put a box around my square root. And this is the first time where this box is really going to be useful to me. I want to get the square root by itself. Is the square root by itself here? Is the square root by itself? I need somebody besides Claire. I'm starting to think she's the only one that knows what she's doing in here. No, the square root's not by itself. So what can I do to get it by itself? Yeah. So we need to get rid of this minus 3 here, and we'll do that by adding 3. So we're going to add 3 here. We're going to add 3 here. And when we do that, the 3's cancel out. And what's left over here on the left side? On the left side. Is it just d plus 1? It's the square root of d plus 1. That square root's still there, right? And, Kayshawn, what do we have on the right side? 9. Okay, good. Okay, now, we have the square root by itself. So what do we do next? We square it. So we've got the square root by itself. Now we have to get rid of the square root. So we do that by squaring it. So we square the left side. We square the right side to keep it balanced. And what's going to happen? The square root and the square cancel. What's left?
D plus 1.
D plus 1. And on the right side?
18.
9 squared is... 9 squared is 9 times 9, which is 81. Now what?
Take away 1.
Now we subtract 1 on both sides. This is the solve as usual step. The 1's cancel. We get d by itself on the left. And 81 minus 1 is 80. What do you guys think?
It's cool, but it's not.
This one's not a whole lot different than the last one. It's just we have to do a different operation to get the square root by itself. I want you to just take a couple of seconds here to try to get it started, and then we'll go over it together. After I circle the variable and draw the line, what is the first thing I'm going to have to do here? I need to get the square root by itself. I need to get this by itself, so what do I have to get rid of? I've got to get rid of that 2. And how do I get rid of a divided by 2?
Times the 2.
Multiply by 2. So I multiply both sides by 2. And when I do that, the 2's cancel, and what's left on the left side?
F minus 3. Square root of F.
The square root of f minus 3. And on the right side? 6. Now the square root's by itself, so what can I do? Chris is absolutely right. We have to square it up. So we square both sides here. That square is going to cancel out with the square root. And what's left then?
F minus 3.
F minus 3. 6 squared is 6 times 6, which is 36.
And then plus 3. 39. F 39.
F equals 39, right? Don't forget your equal signs every step along the way. Cool? Okay, a couple more. Just want to make sure that you're good at these before I give you the worksheet.
Say cool with.
So we circle the variable, we draw the line. I've got the box around the square root because the first thing I want to do is get the square root by itself, and we have to get rid of that 3. Now we just had a good question. That 3 is being multiplied by the square root. How do we know it's multiplication?
Because you're right next to it.
Because it's right next to it. There's nothing there. So if there's no operation between two things, that means that we're multiplying. So this is 3 times the square root. So what do I do to get rid of that 3?
The opposite is
The opposite of multiplication, which is
divide.
division. So we're going to divide by 3 on both sides. And when we divide by 3, the 3's cancel, which leaves what?
G. Square root G. Yeah, you know.
The square root of G minus 7. Okay, good. And on the right side, 9 divided by 3 is 3. Now what? We're going to square both sides. And that square is going to cancel the square root out. So the square root and the square cancel. And what's left on the left side? On the left side, G minus 7. On the right side, we have 3 squared, which is 3 times 3, which is 9. And then add 7 to both sides. 7's cancel. We get G is equal to
16.
That's not too bad, is it? All right, the last one's going to be the most fun. I'm going to give you a minute to get started here. See if you can get it on your own. This problem is a really good example of a problem where putting a box around the square root just really helps you visualize what you need to do. The first thing we have to do to solve an equation with a square root is to get the square root by itself. Well, we have 2 things here that are with the square root. We have the 4 and we have the minus 5. Which one do we need to get rid of first? The minus 5. Why? Yes, exactly. So if we were doing order of operations, we would do 4 times the square root first, and then we would subtract 5. Remember, we do order of operations backwards to solve the equations. So since the minus 5 is the last thing we would do with order of operations, it's the first thing we have to get rid of. So we're going to get rid of that minus 5. And to get rid of the minus 5, we add 5, right? You guys agree with that? The minus 5 and the plus 5 cancel. And when those are gone, we still have all of this here. So we still have 4 times the square root equals 16. Okay, good. We still don't have the square root by itself, though. So what do we have to do to get the square root by itself? How do we get rid of that 4? Divide by 4, exactly. So we're going to divide by 4 on both sides. When I divide by 4 on the left side, the 4's cancel. And what's left? Square root of h minus 12. And on the right side? Okay. Now what?
Square 2.
Okay, so now we have to get rid of the square root. And to get rid of the square root, we square it. And if we square the left side, we also have to square the right side. And the square root and the square cancel, and what's left over there? And on the right side, we have 4 squared, which is 4 times 4, 16. And now we get the h by itself by adding 12 to both sides. 12's cancel. We get h by itself on the left side and 28 on the right side. So, like I said before, solving these types of equations have 2 steps to them, basically. I know you wrote down 3 steps, but the first thing you have to do is get the square root by itself. And you do that just the same way we got the variables by itself before. Then you get rid of the square root, and then you solve the equation like we used to, where you get the variable by itself, using the golden rule for everything. Does anybody have any questions about any of that? All right.